Okay, what I'm going to do here is an 8-row truth table. So these 3 columns here are my reference columns, right? So I have, notice, 3 different statements, P, Q, and R. If I have 3 different types of statements, then that means I'm going to have 2 to the 3rd power of rows, and that's 8. So I'm going to assign the reference columns here in the same exact pattern. So the far rightmost reference column is going to have the pattern of alternating trues and falses like this. The next leftmost, the column left of that rightmost column is going to have the pattern true, true, false, false. Okay, all the way down until you finish. Whoops. True, true, false, false, true, true, false, false. And the one left of that is going to have the pattern 4 trues and 4 falses. So you can see that there's a kind of exponential pattern forming here, like this. So these are my reference columns, okay? This is what I've assigned to R, this is what I've assigned to Q, this is what I've assigned to P. You should always put these in alphabetical order. So if I had A, B, and C, for example, the A would be the furthest left, the C would be the furthest right. Alright, so I've assigned my reference columns for my truth table. Now I'm going to determine the truth values of these 3 statements. And what I'm actually going to do, I'm going to treat this as an argument from this premise, if P then Q, and this premise, if Q then R, to this last column, as I'm going to treat this as the conclusion. Okay? So my question is going to be, is the argument from these 2 premises, let me see if I can select both these, is the argument from these 2 premises to this conclusion a valid argument or not? So we have to determine the truth values. So here what I'm looking at is the columns P and Q, right? So these 2 columns are what I'm looking at to evaluate this statement. So a true and a true is true. A true and a true, again, true. A true and a false, right? Here the consequent is false. Q is the consequent of the statement I'm evaluating. So if you have a true antecedent, false consequent, that conditional is false. Here's the same thing again, true and a false, false. All these other ones are going to be true, and the way I know that is because if I look down at the antecedent, I see they're all false. And we know for the truth table of a conditional, if the antecedent's false, then the conditional is always going to be true. Doesn't matter what the consequent is. So these are all true. Okay, let's go on to the second one. Here we're looking at the 2 columns Q and R here, right? These are the 2 columns. So when Q is true and R is true, then the conditional is true. Whoops, true. When Q is true and R is false, R again is the consequent here, that the conditional is false. Here we've got a false antecedent and a true consequent. That means the conditional is true. Same here. True and true. It's true. Here's another true and false. That means the conditional statement is false. And then both of these are true because the antecedent Q is false in both cases. In the last one, we're looking at P and R. So look, what we're doing here is we're evaluating this column, P, and this column, R. Sometimes it can be tricky to keep track of the columns here, but just we're looking at P and R only here, right? Those are the propositions involved in this statement. So a true and a true is true. True and a false, false. True and a true, true. True and a false, false. Then now look at the antecedent. here. Again, they're all false, so we know if the antecedent is false, the conditional is always true. So now I've completed my truth table. And the question is, if we treat these two columns as the premises, and this column, the last column, as the conclusion, the question is, when applying the truth table test of validity, is there any row on which both the premises are true and yet the conclusion is false? Well, the first row isn't one, because although both premises are true, the conclusion is also true. Here, both premises aren't true, so that's irrelevant. Same with here, same with... Here's a case where both premises are true, but in this case, the conclusion is also true. Both premises aren't true there. The premises are true here, but the conclusion is also true, right? And the last row, same thing. So look, what we found here is that there's no row on which all the premises are true, and yet the conclusion is false. There's no such row, and that means the argument is valid.